So this is a run through of the sample assessment paper 3. This is the macro and microeconomics combined, a synoptic paper. 2 hours in total. In the exam you'd have wrote your surname up here, your name here, centre number, candidate number. The information that you might skip over but is important for all the exam papers. Black pens, bring lots of them. 2 sections. Section A, answer questions 1A to 1C, so these are compulsory questions based on the case study, and then a choice question. So you've got 3 questions plus a choice in section 1. That's half the paper, so that's 1 hour. And then again in section 2, another case study, 3 questions, and then again a choice. So the 2 halves of the paper structurally are exactly the same. Total is 100 marks, so you want to get through 25 marks every half an hour or every quarter of the exam. It says there the marks for each question are shown in the brackets. Use this as a guide for how much time, so they're telling you to kind of use that for your timing. Read each question carefully before you start, so spend a little bit of time looking at the questions. Try to answer every question, so it's better to have done bits of all the questions rather than missing some, and check your answers if you have time at the end. Okay, so before we look at the kind of case study, those are the 3 questions at the top that you've got for the case study, and then here are the 2 choice questions. So question 1A, with reference to figure 1, so you're going to use some kind of data table, explain 1 possible, and remember when it says explain 1 or explain 2, you don't need to do any definitions in this question. Your K mark is going to come from that cause. 1 possible cause of the forecast change in total energy use. So there's going to be a change, either an increase or a decrease, and you need 1 possible cause of that. With reference to figure 4, again looking at some data, examine the likely, so what's the most likely effect on the circular flow of income of the trends in exports and imports. So it's going to be telling you whether the value of those are increasing or decreasing between 2000 and 2020. Examine is the same as assess, so if you're going to annotate this, you could just change that to assess to keep you right. Impact is going to be positive or negative impacts. Again, a little bit of annotation might keep you in the right direction. Question 3, with reference to the information provided, so it's telling you they want you to use the case study. Discuss, so that's going to be 2 sides plus a judgment. The likely impact, so again if it's 2 sides it'll be a positive or a negative, of a change in the price of gas on the markets for solar energy and nuclear energy. Now because this last part says market, you know that this one is a micro question. Circular flow of income, macro, explain 1 possible cause of the change in total energy use. Probably, and if we look at the data, this is going to be a micro one. Then the next 2 questions, you've got a choice for your essay. So that first section would be 30 minutes or quarter of your paper. This next section is going to be 30 minutes as well, so you need to stick to those timings. With reference to the information provided and your own knowledge, so you can bring your own case studies into this. Evaluate the micro and macroeconomic effects on the UK economy of the government's decision to encourage fracking. So you could see fracking as a supply side policy. You can also see it as a microeconomic, just supply and demand. With reference to the information provided in your knowledge, same as the previous structure, evaluate the possible macro and micro effects of the global economy of lower energy prices. So as it says global economy, you're probably looking for the countries that export energy, and the current countries that are net importers. So net exporters are countries that export more than they import, and net importers, like the UK, import more than we export in terms of energy. Okay, so this is the start of the case study. We know the first question was looking at the cause of the forecast change. So we need to identify the change, and as you can see, up until 2011 is the light grey, which is lower in all instances than the forecast for the future, which is an increase. So what we're looking for is a possible cause from the rest of the case study of that change. The next figures, so it doesn't actually ask you any questions specifically about these figures, but they could be useful. You have an increase, a slow then a rapid increase in gas production, or natural gas production, especially from about 2005 onwards. You also have the natural gas price, which has been very volatile, and there's some price spikes through that period, but in terms of a rising trend, it's now coming down quite significantly, linked to that increase in supply. So that's an increase in supply, and that's the market price coming down. This is the question that was looking at the impact of the change in imports and exports. So USA is the market it's looking at. It's currently increasing its exports. Its imports are marginally coming down, but it looks like by 2020, so not currently, it will become a net exporter in natural gas. Okay, now looking through the rest of the case study for information around those different questions. So this extract, Britain needs to embrace the global shale gas revolution. This is the one linked to the last question about encouraging fracking. Britain's sitting on lots of energy in the form of shale gas, yet to failing to make use of this resource. Politicians imposed higher energy costs on the publics thanks to so we've got taxes and environmental rules, so environmental rules, regulations, same. These have hit the poor, contributing to declining real incomes, crippling manufacturing companies and exporting jobs to their countries. So here we have some potential benefits of increasing or helping to increase the supply of energy. So it'll increase people's real incomes, it will help out manufacturing companies and keeping jobs in the UK. It's how to change the current energy policy and begin to exploit the UK's onshore shale gas reserves, which could deliver a vast amount of cheap, clean energy. So it's also implying here that it's a cleaner energy source than what we're currently using, which is coal-fired. 2 years ago, experts put these at 5.3 trillion cubic feet, but now seems that British will significantly increase this estimate by as much as 200 trillion cubic feet. Exploration companies claim to identified resources of nearly 300 so far. Offshore reserves, which are much harder to extract, could be as much as 5 to 10 times larger. So there seems to be a significant amount if we're looking at the potential there. A report from the Institute Director states that the benefits of embracing shale gas will be greater than the costs. The USA is leading the way. Shale gas now accounts for 33% of domestic gas production and 22% of gas consumption. So it's saying that it does have the potential to replace significant amounts of energy use. Energy prices have gone down, so there we've got the evidence for prices falling, whereas in Britain they've gone up. Major competitive advantage to the US, so you've got potentially kind of exporting international competitiveness from a macro point of view, further damaging UK industry. One side effect of the shale revolution is that the UA natural gas price no longer moves in line with the oil prices, so they've decoupled themselves from high prices. The impact of the USA's shale revolution is a success story that's gone largely unnoticed in the UK. USA's economic problems would be far worse without it. By 2020, shale gas is expected to create 3.6 million US jobs. So again, a significant number of people employed. Directly and indirectly, carbon emissions are falling. So again, a micro benefit, we could analyse that as a reduction in a negative externality, as gas is cleaner than coal. Boost to the British economy from shale gas, it calculates 35,000 extra jobs. So there's a boost in terms of positive externalities, helping to offset the decline in North Sea oil. There would be enough onshore supply to meet 10% of our gas demands for the next 100 years. UK carbon emissions would be cut by 8%. So again, a specific figure there that we could use. The controversy is it would cause earthquakes, potential negative externality, that the possibility certainly exists and needs to be taken extremely seriously. Yet in 2012, the UK experienced 3 earthquakes, larger or bigger than the 2 caused by fracking in 2011, and none of these caused any damage. So even though there's potential for negatives, currently they didn't cause any damage. Few people even noticed them. Further concern is it requires considerable amount of water and may cause water contamination. Maybe a better one to analyse as a negative externality. We've already learned from oil spills and nuclear accidents. The trick with flagging is to use safest method to engage in continuous monitoring of its effects and assure safety. The next extract, the impact of cheap shale gas. This one a bit more of a focus. Cheap domestic gas will have 3 effects. It will delay or kill most competing source of electricity production. So there is a kind of a nice it depends upon point here of it reducing investment in the long term for potentially even more sustainable forms of energy. The gas is now incredibly cheap and easy to acquire, while other energy sources remain expensive or hard to get. So gas is winning, coal is being pushed out, nuclear is stalled, and wind and solar projects are being cancelled. So we are becoming reliant on just a different, slightly less polluting fossil fuel, but it still is a non-renewable resource. Natural gas has become so cheap it will win over some transportation markets. So potentially being used for transport, which currently is quite a significant contributor to greenhouse emissions. The third effect will be on greenhouse gas emissions. Most new plants will run on natural gas. This is cleaner than coal, but it's dirtier than nuclear, wind and solar. So that's kind of a nice wider context for evaluation. Although some aging coal plants will be replaced, far more nuclear, wind and solar plants will be deferred or cancelled in favour of gas. Moving to a gas-powered grid will almost certainly result in more greenhouse gas emissions over time. So again, this is kind of that long-term evaluation of, is this the best for the economy? Gas leaks in production, shipping and distribution processes, an agent of global warming. Natural gas is more potent than CO2. So even though we might be reducing CO2 emissions, if we actually let some of this natural gas escape into the atmosphere, it's a lot worse. Okay, so this first question, remember it says one possible cause of the forecast change in total energy use. Well, we have an increase in the quantity in all of the markets. You could refer to any of the types, coal, oil, gas, and so on. It's crying out for you to use a supply and demand diagram. There are 2 possible ones you could use, depending on which cause you go for. If you went for population growth, because it says possible, especially in developing countries, then you'd have an increase in demand, and then you would refer to the quantity being the thing that's increasing. So the forecast change in total energy use, the word use is referring to this quantity on the bottom. So you'd want to give it the market for coal, market price, and the quantity going up. Now, the better ones may be to look at, or a better answer in terms of economics would be to look at rising incomes from economic growth. So economic growth equals a rise in disposable incomes. As energy is a normal good, and if you want to be even more accurate, a normal necessity, 10% rise in income would lead to a 3, 5, 10%, whatever, less than 10% rise in quantity demanded, and then refer back to the quantity increasing here. The one that is different and the one to be careful of is the natural gas market. If you choose this one, the price in the market, even though the quantity is increasing, the price is falling. And the reason for this in this market is the increase in supply from the American market. So this is the different one. There's lots of different factors you could use for the increase in demand, but the key one here is the reduction in the price, which is due to the increase in supply, which is going to cause an extension in demand, whereas this is going to cause a shift outwards, and that is a key step in your analysis of that question. But here, the extension in demand is the key step if you're using the increase in supply. And if you use the natural gas market, because the price is coming down, you can't just talk about the increase in demand. What is likely to happen is that people will switch from a substitute market. So whereas they used to buy gas, now they used to buy oil, they now buy gas. Drawing the graph will be helpful to get more analysis marks, but those two key links in the chain will be what the examiners are looking for. And if you draw the graph, refer to that increase in quantity. That is the key thing which answers that part in terms of energy use. Okay, the next question, with reference to figure 4, examine the likely impact on the USA's circular flow of income of the trends in exports and imports of natural gas. So if you remember the circular flow of income, the circular flow itself is the flow between households and firms. From firms to households, we have output and income, and from households to firm, we have expenditure. You then have your injections and leakages, and the two key ones that need analysing are exports and imports. The reason for that was that exports were rising and the value of imports was falling, and it was likely, even though it hasn't gone into positive, it is an improving situation. So the value of this is rising and the value of this is falling. So what you do have is you have an increase in injections and a reduction in leakages. What that will mean is that the value of the output, income and expenditure within the economy will also rise. As output, income and expenditure also affect consumption, you can analyse this as a potential increase in aggregate demand. As this is an examine question, and because you've got the word likely, it needs a second side. Just before we do that second side, we also want to remember to do a little bit of application. The application is those trends. So what you have is that the gap between, you can either say the gap between exports and imports is shrinking. So you could even talk about it in terms of the deficit between the two of them. However, there is still a net leakage, because even in 2020, the imports are greater than the exports. So reference to that graph is key, because that will give you your AO2 marks. So coming back to the evaluation for this, two ways to do it. One nice way with this is that it's the trends are up to 2020. So what you have is that some of that is a forecast. So same way that you can evaluate elasticities, they are forecasts of the future. They're not 100%. And it could be that either exports ends up greater than the imports. so it increases at an even more rapid rate, or that the exports fall and you end up with a significant import greater than export. You could also look at what's happening to the other injections and leakages. So it could be that even with this improvement, you have an increase in taxes, and that would offset any benefits to the circular flow. Okay, so the last question in the case study part, it's a discuss question. So we want two sides and an evaluative conclusion. We know it's an impact question, so it's going to be positives and negatives. And here we have price of gas on the markets for solar and nuclear energy. So the case study itself tells you that as the price falls, it is likely that the quantity demanded for solar and nuclear will also fall. You could draw the graphs for this. So you have the supply of natural gas increasing, and then you would have the demand falling for the other market. You could link it through XED as they are substitutes. So the potentially a 10% fall in the price of gas could lead to a 10% fall in the quantity demanded of nuclear or solar. In terms of the negative, when you are doing an evaluative question around markets, so around supply and demand, some of the best ways to do the other side is around elasticities. So if you make, because it's demand changing, supply very inelastic, what you can do is, even if the demand falls, the quantity might not fall too far. So the price might fall for the nuclear and the solar energy, but the demand might not fall significantly. The other thing you can look at is things like irrational behaviour. So why would a customer still stick with solar and nuclear energy rather than moving to natural gas? So it may be things like inertia. If they've already invested in solar panels on their house, they're not going to start purchasing natural gas to heat their homes. It could also be habitual behaviour. They stick with a supplier who is supplying nuclear power rather than switch to a different supplier that is supplying shale gas. In terms of the judgment, although it depends upon, a key one here would be time. So there is going to be a time lag in terms of when that switch would happen. So especially saying if it was like the UK, for example, that people will already have infrastructure, they will have contracts with energy providers that may last 1 or 2 years. So the reduction in price now may not lead to that switch until some point in the future. In terms of the size, and this would be a good way to link the two markets of solar and nuclear, it would depend upon the size of that XED. So as an example, if the demand for nuclear energy, or the cross elasticity of demand between nuclear energy and gas was say 1.5, but the XED for solar was 0.5, then that 10% fall in the price of gas would lead to a 15% fall for nuclear, but only a 5% fall for solar. So it might be that the impact on those two markets occurred a different amount depending on the cross elasticity. Potentially maybe the people that buy solar energy do so for different reasons than the people that buy nuclear energy, so they'd be less likely to be worried about a polluting form of energy.